All right, everybody. Hello, hello, hello. And we're back at it. All right, back at it here. And I was talking about going backwards here, right, for today's lesson. Given a graph, writing the equation. And I gave you this algebra 1 type here, and that was, under the assumption that the leading coefficient was 1. And or not, sometimes that'll happen, but sometimes, you'll have other leading coefficients. Now, if you remember, you had something like, just to mention here, something like, what if we had like a 2x squared? And a 1/2 x squared. Y equals 2x squared. It is a parabola, but if you remember, y equals 2x squared looks something like, something like that. I might get out the calculator here in a second. And then 1/2 x squared, would look something like that. Let's see if I can get the calculator up here. Yeah, okay. All right, so the y equals, so let's take a look at x squared first, right? Y equals x squared, your standard, and then we'll take a look at 2x squared. The blue is the x squared, and the red is 2x squared. All right, it didn't, the vertex is still 0, 0 for both, but in terms of what happened, what do I usually get, with y equals 2x squared? It becomes more narrow, than the graph of x squared. Okay. And what's causing, all right, what's causing it to become more narrow than y equals x squared. And this is something I think we'll get into a little bit in the next unit. It's that coefficient of 2. All right. Causes, that to happen, with y equals 2x squared. To have it become, closer to the y-axis, Like I said, I'll get more into discussing that. I believe that pops up in the next unit. But I just want to give a little background here. Now, in terms of 1/2 x squared. All right. So 0.5x squared. Let's see what that. All right, so blue is x squared, red is 1/2 x squared. So now you can see it's what do I usually get? Well, it's wider, right? The graph of y equals 1/2 x squared is wider, right, than the graph of y equals x squared. And that's true, There's another way to look at it. The same way there's another way to look at the graph of 2x squared. I said it's, becoming closer to the y-axis. That's true, but there is another way to look at it, and that's what I meant in terms of, me explaining those graphs. Like I said, we'll do that in the next unit. Now, I guess I'll still talk about this exercise number 1 here. So it contains the point 2, negative 50, right? So I worked backwards. I got x plus 3. I got x minus 4. Now, if I put that function here, let me take a look at that quadratic. X squared minus x minus 12. 2, negative 50. I don't know about that. Let me see. So this is what I mean. I'll talk about it a little bit here. So when x is equal to 2, right, I'm at 2.17, but it's nowhere near negative 50 for y, right? And I can confirm this on the table, right? When x is equal to 2, y is equal to negative 10. So 2 comma negative 50 is not on a point on x squared minus x minus 12, which means what? The leading coefficient of this parabola is not 1. So what do we do? Well, let's see here. I guess I'll do it now because this is what we'll do with the polynomial functions, you know, when we get to cubics and stuff. There we go. So like I said, the leading coefficient here, let's get rid of this. So what we're going to do to figure out what the leading coefficient is going to be for this parabola, this exercise 1, I'm going to work off of the factored form. And what we need to do is we got to figure out what that leading coefficient is going to be. So I'm going to call that A. Okay. So we're going to use the factored form. We're going to use the point here, that's not a root. That's not a root, right? To help us find the leading coefficient. All right, so we're going to use this, the 2 comma negative 50. That's not a root, right? We're going to use the factored form and then that, the A here to solve for that leading coefficient. This is the leading coefficient here. And I know it's not a 1, right? Because we just saw it on the calculator. So how are we going to figure out what that leading coefficient is? Using the factored form, using what I have right there, and also understanding that, 2, negative 50 is a point on that parabola. That's, this is my x, right? And this is my y. We'll take a look, right? I mean, I'm looking to solve for A here. A is that leading coefficient, right? So I have an equation here with A, X, and Y. I need to solve for A, right? I know 2 and negative 50 is a point on this parabola. I can make 2 my X, right? Negative 50 my Y to solve for A. So if I put negative 50 in for Y, is going to equal A, plug in 2 for X, times 2 plus 3, times 2 minus 4. Can that get me to solve for A? I think so, right? That would be A times 5, negative 2 take away 4. Oh, wait, positive 2, pardon me. This is positive 2. So that would be negative 2 here, right? So that would be negative 50 equals negative 10a. Right, divide both by negative 10, and there we go. 5 is my a. And I just plug that in now. So I would say the equation here would be y equals 5. Parentheses, right, x plus 3, parentheses x minus 4. You don't need to multiply it out. I know it says standard form here, but I'm not really concerned about that right now. it says standard form, like, to finish this off, I mean, but like I said, we would have to multiply this out, and I don't feel like doing that right now, so there you go. All right, so let's see here. 5x plus 3x minus 4. Let's see if 2 negative 50 is a point there. Hopefully it will be. Let's see. Here's the calculator. So 5 parentheses x plus 3 times x minus 4. The graph, I'm not really concerned about that right now, right? So let's go to the table. And what did we say? X equals 2. Yeah, 2 negative 50. There you go, right? So the leading coefficient here, yes, is 5. So that's what we're going to be doing here, people, all right, with, cubics and quartics and stuff like that. Keep in mind, when we sub in for x and y, it cannot be a root. It cannot be a root. We can't plug in, negative 3, 0 here, right, into this equation, into the factored form. You can't put in like negative 3, 0 here or 4, 0 to solve for a. Because if you put in a root into this equation, right, think about it. 0 goes in for y, and then you put in negative 3 for x. Negative 3 plus 3 is 0. 0 times, negative 7 times a is 0a. 0a equals 0, right? That's indeterminate, by the way. So you cannot plug in a root for x and y to solve for a here. All right, so, I'll have points on the graph. It's not like you have to, guess here. There'll be points for you, or a point to use. It'll be indicated. All right, but just understand it's not going to be don't plug in a root. All right, let's do this one. Exercise 3, page 29. So now a cubic, right? Create the equation of a cubic in standard form that has x-intercepts, all right, of negative 4, 2, and 5. So like I said, what we'll do here is work backwards, right? If negative 4 is a root, then x plus 4 is a factor. If 2 is a root, then x minus 2 is a factor. If 5 is a root, then x minus 5 is the factor that led to that root. So, like I said, we're going to be working backwards here. So I'm going to say y is going to equal, now I'm going to leave a little space here, parentheses, x plus 4 times x minus 2 times x minus 5, right? Working backwards to get the equation. That's what they want here. Like I said, I know it says standard form. I'm not really concerned about that. Okay. Now, like I said, the one thing here you got to understand is, we got to see, right, what the leading coefficient of this cubic function is going to be. We need to find that. Can't assume it's going to be 1, right? I mean, think about the last example, right? The leading coefficient was 5. So we need to solve for a here to see what the leading coefficient is going to be. It very well may well be 1, but we don't know for sure yet. We need to figure that out. And in order to do that, we're going to take this point here that's on the cubic, that's not a root, and we're going to plug that in for x and y. Okay, 6 is going to go in for x, and 20 is going to go in for y into this equation in factored form to solve for a. So 20 is going to equal a times 6 plus 4 times 6 minus 2 times 6 minus 5. 20 will equal a times 10 times 4 times 1. 20 will equal 10 times 4 times 1 is 40a. Divide by the 40 here. 20 over 40 is 2 over 4 is 1 over 2 reduced. So this leading coefficient is a half. I'm going to plug the 1/2 back in for a. And I'm going to get here y equals 1/2 times x plus 4, no specific order here with the factors, times x minus 2 times x minus 5. I'm going to write my answers in factored form. I know, like I said, it says standard form here. Standard form, we'd have to multiply this out. It's more work, but it's not anything, like crazy difficult. So yeah, so a 1/2 here. So yeah, it's, we'll get fractions as leading coefficients. All right, as I talked about with the, the 2x squared and the 1/2 x squared. All right, so there you go. I'll stop it here for now, and then we'll come back and do more of these because, what's going to be involved here, just like, what happened before this, right, when we